Now let's move on to this question. The points A and B have position vectors, this and this, respectively. So which means OA is given to you by 1, 7, 2, and OB is given to you by -5, 5, and 6. Okay, now part 1, we have to use scalar product to find the angle AOB. So pretty easy. So that will be OA times OB. That will be magnitude of OA times magnitude of OB cos of the angle in between, which is angle O. So we have to use this formula to find the value of the angle. Now this is simple. OA is given to you 1, 7, 2. OB is -5, this. And this one will be what? Will be 1 plus 49 plus 4, that should be root of 54. That will be 25 plus 25 plus 36. That will be 86. And then what else do we have? That's it. We just have to simplify and solve for the value of O. So that will be dot product, scalar product. So 1 times -5 is -5 plus 35. So -5 plus 35 plus 12 divided by this. And this is cos of the angle O. So solve. -5 plus 35 plus 12 divided by root of 54 times root of 86. That will be 0.6163 cos of the angle. So the angle will be simply cos inverse of 0.6163. So cos inverse of the value should be 51.95. So here we have to give your answer correct to 3SF. That should be 52.0 degrees for your value of the angle. Here again I have to find the angle in radians. So my apologies. Cos inverse 0.6163. That should be radians. That will be 0.90676, which is 0.907. Correct to 3SF. Now let's move on to part 2 of the question. The point C is such that we have this equation. Find the unit vector in direction of OC. So let's first find OC, right? So here we have what? Let me separate those two. I have AB here. AB is given to you by OB minus, so let's find this first. AB is given to you by OB, which is this, minus OA. That'll be 1, 7, 2. So -5 minus 1 will be -6. 5 minus 7 will be -2. And that should be 4. So AB is given to you by this, which is -6 minus 2, 4. 2 times BC. BC is OC minus OB. OB is given to you by this, 5, 6. So again, you have to know these kind of, how to find those directions. For example, we have to know AB is equal to OB minus OA. You always take the second one first. So here we have B. That will be OB minus OA. Here we have, as you can see, we have BC. So again, the same idea. We take the second one first. So OC minus OB. Why is it this way? It is actually because of the diagram that we use. I think I've explained this in a previous video. If you guys want to search this on the channel, you can search vectors and you will find a video explaining why AB is equal to OB minus OA. It is simplified. You have to explain, but it's pretty easy as well. But the main idea is that when you have to find this, look at the first, or you have to look at the second one and write this and this. This is the idea behind this, for you to know this, to know how to do this fastly, so you don't have to waste your time in this case. Now let me solve this. You have to divide by 2. That will be -3 minus 1, 2. Now again, the reason why I'm going on with this is because I get this question all the time. Why is this in this way? You have to know, okay? Now so that will be 0. So OC minus this, this, and this. So OC will be what? Simply send this over here, will be -3 minus 1, 2 plus -5, 5, 6. That will be what? So -3 minus 5 will be -8, minus 1 minus, so plus 5 will be 4, 2 plus 6 will be 8. So OC is found to be this vector. Now we have to find the unit vector in the direction of OC, so pretty easy. So we also have to find the magnitude of OC. That will be pretty. We have to find this 64, which is 8 square, plus 4 square is 16, and 8 square will be 64 as well. Now again, minus 8 square is the same thing, right? It will be 64. 64 plus 60, 16 plus 64, that should be root of 144, and that should be 12. Let's check. That is 12. So finally, OC, or the unit vector in direction of OC, will be minus 8, 4, 8, divided by the value of 12. That should be, you can divide by 4, you will have 1 over 3 multiplied by minus 2, and you have 1 and 2. That will be the unit vector in direction of OC. And that will be a question in relation to vectors for this paper.